Okay, ladies and gentlemen, when we were dealing with arithmetic sequences, as we move to the right, we know we're adding a value, which is why our formula requires addition inside. Now, if I said find the general term or the general expression for this sequence, what would you guys do if I said find the general term? What was your first step with an arithmetic sequence if I said find the general term or find the explicit formula? What would you do? Where would you begin with that with this arithmetic sequence? When you're finding the general term or explicit formula, we determine the definitive values, like the values that will never change in a sequence. What are the two values that will never change in a sequence? They're definitive, they're solid, they're never going to change. Yep. So T1 here is 5. And then what other value is just, it's consistent? Yeah. The D value of 3. Okay? These are definitive values, they're never going to change. If n is 10, the Tn changes. If n is 12, the Tn changes. The n and the Tn are the variables of a sequence. Okay? So when we did this, we would actually put our definitive values in. The T1 will never change. My common difference will never change. And we kind of worked on coming up with the explicit formula. And we put our like terms together. And we would get our explicit formula. And this was kind of like, and it should remind you of y is equal to mx plus b. Our rate of change is 3, which is our common difference. And we did this, right? This feels comfortable. You guys you've been asked for the general term a few times. You know you're going to get to the general term. So this is for an arithmetic sequence. Now, here, you've been asked to find the general term of a geometric sequence. So determine the nth term. This is called the general term of a geometric sequence. So when you're thinking about geometric sequence, right away we need to write formula. Tn is equal to T1 times r to the power of n minus 1. Remember, when we're multiplying r times r times r, we get an exponent, not a coefficient, right? So if this is my formula, what are my definitives of the formula? My definitives are going to be my T1 and my common ratio. Tn remains unknown, and n, this is your explicit formula to represent this sequence. And all we have to do is plug in T1, common ratio, and I can't simplify anything. There's no need for simplification. There's nothing to be simplified. This is the formula for this particular sequence, and it happens to be geometric, and that's it. These are not the same base, so I can't use my exponent laws to simplify. We're done. Okay? So, when you're looking at this, we need T1, and we need the common ratio. Guys, what's T1 and what's my common ratio? Okay, so T1 is 6. And then if you're not sure, you would take your T2, divide by T1, and you get your common ratio of -3. And it's, for this sequence, your explicit formula, I'm actually going to write the formula out one more time. So we grab our T1 will never change. My common ratio does not change. The variable is n and Tn. This is like your x-axis. This is like your y-axis if you were to graph it. Your T1 is 6. Your common ratio is -3. If you don't put brackets around a negative exponent before you take it to a power, you're technically not correct. You have to put brackets around your negative number before you take it to an exponent. Okay? So let's see if we can handle this guy down here. If we're going to find general term, we need this and we need this. Do we have them both? Could we determine the R value? Could we use the information given to determine the R value? Because that's what we need. We need the R. Can we use this formula to algebraically determine the common ratio? Here I'm going to say n is equal to 5. Are you guys okay with this? So Tn is 1,792. T1 is 7. I don't know R, but I know that if I'm using this as my Tn, then n must have been 5. Yeah? Okay, so let's clean this up just a little bit. How would I solve for R if R is taken to the power of 4? Let's first, like if I want to isolate for R, what's your next move? Yeah.
Divide by 7.
Yeah, we're going to divide by 7. Make sure you show your work. So whatever I do to one side, I do to the other side. And we end up with what? 2 and 5, 256. Can you guys double check that? Is that right? Okay. Now what did we talk about in terms of even exponents? Like, do you guys remember we had a conversation about even exponents? When I'm going to solve for R, what do we need to remember when we have an even exponent? What do we got? It could be positive or negative. So guys, notice this wasn't creating same base because we weren't looking for the variable exponent. We were looking for the base. So in grade 10, you guys would have recognized that this would be positive negative 4th root of 256. If it's an even exponent, your common ratio could have been positive or it could have been negative. There's nothing definitive that says it had to be positive or it had to be negative. And that's when there's an even exponent. Guys, when you take the 4th root of 256, what do you get? Is it 4? So your R value is either positive 4 or your R value is negative 4. So when I'm coming up with my general term with the T1, I actually have to write both possibilities. And if you don't give me both possibilities, you're really just not going to reach that benchmark of perfection. This is one possibility, or this is the other possibility. Making sure you put brackets around your negative exponent. Now, those who have really old calculators that don't go to a superscript, you might want to get into the habit of putting brackets here. Like the really old calculator doesn't put your exponents in superscript. How many of you guys have an old calculator that doesn't go to superscript on your exponent? Does anyone have like a TI-83? Everyone try this really quickly. In your calculators, when you go 3 to the power of 5, does it go superscript on you? If it goes superscript, you're good. Does anyone, superscript means it's like it's up high and it's little. Did your exponent go up high and little? Or does anyone have a calculator where it didn't? It just stayed big on the side. Does anyone have a big on the side one? Okay, we got good calculators. We're good. We're good. We're good. Okay. So guys, on this one, there was 2 possibilities for my general term, and both of them have to be acknowledged. You're not shooting for 50%. You're shooting for, like, you want to get full marks. And so how do you get full marks? You got to recognize that if you're taking the 4th root or the 6th root or the 8th root or the square root, those are even exponents, and you have to acknowledge the positive negative. Okay? Could you find T1? Because we know if we're going to find the general term, my general term needs a T1. Like these 2 components are needed. And right now, we don't have them. Could you find T1? I have my common ratio, but could you find T1? Okay, so clearly, in this particular case, n is 8. So using the formula, okay, so guys, no one is talking when I am. And if you don't have the self-control, keep your mouth shut when I'm teaching. Don't sit with your friends. Okay, this is the one time I'm going to tell you this. Okay, it's rude and it's disrespecting everyone else in the room and the quality of learning they're getting because you're so arrogant you think you need to consume the space. Stop. There's no talking when I am. Plug everything in and let's see what we can figure out here. My T8 was 1/4. I don't know my T1. I do have the common ratio of 1/4. Now, would it blow your minds if I put a 7 here instead of writing 8 minus 1? Like instead of writing the numbers 8 minus 1, does 7 blow your mind? No. Okay. How could I isolate for T1? How could I effectively... And if you guys are putting in 1/4 to the power of 7 right now, I want you guys to resist that urge because you guys are better than that. Okay, so we're going to do something a little different. Okay, how is the 1/4 to the power of 7 attached to the T1? You guys did it attached by multiplication. So what are we going to do? We're going to divide. And the reason why I said you guys are better than this, as soon as I divide, do you guys see that we can actually use our exponent laws to simplify here? So we reviewed exponent laws for a reason. When I'm dividing powers to the same base, what do I do to the exponents? I subtract them. So what's 1 minus 7? This would be 1/4 to the -6, right? We're subtracting the exponents. Now type that into your calculator for your T1. Rather than getting these crazy small numbers, because 1/4 to the power of 7 is like a really, really small, like it's going to give you a scientific notation nastiness. But if we recognize that we could just move this to the other side by division and using our exponent laws, right? Where did I get that 6? It was 1/4 to the 1 minus 7, which gives me the 1/4 to the power of 6. Couple your math skills with your new skills. When you type in 1/4 to the power of -6, what do you get? What do you get? Is it really 64? Yeah, it should be way bigger. Okay, let's try this again. So, okay, make sure you put brackets around your fraction. And you're taking it to the -6. It should be 4,096. Yeah? Okay. Now, some people use the negative exponent and they turned it into like 4/1 to the power of 6. They got rid of the negative exponent, which becomes just 4 to the power of 6. So some people even took their exponent laws that one step further. So then T1 is 4096. We're not done though. What was the whole objective of this question? What were we supposed to be doing with this question? We're finding the general term. And we need the T1 and we need the common ratio to find my general term. Now I think, yeah, this is more than enough. I'm never going to make you simplify further than this. We just leave it like that. There's your general term. Okay? Go to the whiteboard. This is your chance to talk. You don't talk when I'm talking, but this is your chance to talk. Okay, go to the whiteboard.
I know. No, I need the help of that people. Hey, what did you do now today? All peanut butter.
T3
Doing equations wrong and cups
is 1/3. T7 is 27. Okay, so T3, 1/3. T7 is 27. Now what I want you guys to recognize right now is we know that like n is 3 and 7 at the same time and we don't have T1. When you look at this, I want you guys to recognize that you probably want to show the sequence. So you want to have dash, dash, and then 1/3, and then dash, like so have the empty spots. Make sense of the information that was given to you, okay? Now, this is a geometric sequence. So what you have to ask yourself is as we're moving to the right, we are multiplying by a common ratio, correct? So when I first look at this, so T3 equals 1/3, T7 equals 27. It's not a sum, so I can kind of like get my head wrapped around this. Now, if it was common difference, you'd be adding D's as you move to the right. What's happening in this particular case? If this is T3, and this is T7, how many common ratios am I multiplying by as I move to the right? I want you guys to determine R algebraically. It's not 4R, it's R to the power of 4. Remember that R times R times R times R is R to the power of 4, right? So we know that when we're moving to the right, this is actually 1/3 times. Remember that R, like when you're multiplying R by itself 4 times, that's going to be R to the power of 4, and that gives you 27. I would like you guys to determine T1, and I would like you guys to determine the common ratio and write the general term.
She's with me.
Guys, do you recognize that your R would have been positive or negative 3? So if you just put positive 3, you didn't actually acknowledge the fact that it could have been negative 3. Now, guys, you need your T1 to come up with your general formula. So you're going to basically have two sequences, okay? When you're looking at the two sequences, you're going to have to backtrack and get back to your T1 to figure out what T1 is, because I want the general term formula for both cases. So you should have ended up with, like you should have had R to the 4th is equal to 81, and then R is equal to the positive negative 4th root of 81, and you should have had R is equal to positive or negative 1/3. If you're going to backtrack, you're dividing by 1/3. And so if you're going to divide by 1/3, right? Like, so you're multiplying as you move, sorry, not 1/3, 3, positive negative 3. So 1/3 was your T3. You're going to be dividing by 3, which gives you the 1/9. And then you're going to be dividing by 3, which gives you the 1/27. What happens with the plus minus is this guy in between could have been positive or negative. So you might actually want to show your sequence in two different ways. But your T1, no matter which sequence you deal with, your T1 should be 1/27. Okay? So then your two general formulas, the one is going to be 1/27, 3 to the n minus 1. The other one is going to be 1/27, negative 3 to the n minus 1. Right? If you take 1/3 and you divide by 3, math fraction, you get your 1/9. If you take 1/9, divide by 3, math fraction, you get your 1/27. Yeah? And that should have been your T1. Okay, guys, try this one.
Oh, we set the answer. Neenan. Thank you, Neenan.
Okay, erase what you've got there. T1 is -2. T4 is 54. Determine the general term. So T1 is -2. T4 is 54. Determine the general term. What do you need for the general term? You need your common ratio. Find your common ratio. And once you have your T1 and your common ratio, you should be good to go. Guys, can you take the cube root of a negative number? Absolutely. We can cube root negative numbers. We can fifth root negative numbers. It just means you're going to get a negative number. Okay, guys, your general term should have been Tn is equal to. Now put your -2 in brackets. Just always set off with a negative number. So -2 times your -3 has to be in brackets, taken to the power of n minus 1. Okay?
54.
Okay, now listen to what I'm telling you this time. Okay, so Braden, it should have been negative. Okay, so 54 divided by -2 is -27.
Oh yeah.
54 divided by -2 is -27. So when you cube root -27, which you can, that would be -3.
Really good at this, guys.
Okay, ladies and gentlemen, this is using yesterday's new to you skills. Let's see if you remember those from yesterday. Okay, guys, listen. Okay, listen up. The first term of your geometric sequence is 5. The common ratio is 2. And the final term, your Tn, is 320. Algebraically determine n. This is that process called creating same base. So I'm going to say it again. Your first term is 5, so T1 is 5. Common ratio is 2. Tn is 320. Algebraically determine n.
No, I should figure it out.
Slide over a bit, bumping makes sense. And it's like flip it out over here. Okay, and then slide. And now it's straight.
Oh yeah, you passed.
Bang, 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 bang. Okay, so guys, I want you to look for these benchmarks. Did you isolate your power? Getting 64 is equal to 2 to the power of n minus 1. Okay? Tyler, you have 2 times n, and then n is taken to the negative 1. Your exponents have to be clearly exponent. Look at your 64 is equal to. Make sure that n minus 1 is an exponent. Okay? So guys, then we had to create a same base. You swap out the 64, and we turn that 64 into 2 to the power of 6 is equal to 2 to the power of n minus 1. That's the algebraic process that doesn't feel very algebraic because you're kind of guessing and checking. And then you have to say 6 is equal to n minus 1. And then when you move the 1 to the other side, you should say n is equal to 7. Yeah? Okay, guys, find your chair.
Hey, damn, bring on the peanut butter. I'm so.
Okay. Okay, so ladies and gentlemen, oh, I'm still recording. Yesterday we learned about if we see a percentage followed by the word of, then your common ratio would be that percentage as a decimal or a fraction, but I always like it as a decimal, okay? So if I said 75% of, your common ratio would be 0.75. If I said 25% of, your common ratio would be 0.25. We've got to take this into problem solving where it's not just going to be 75% of, or 25% of, or 35% of. What we have to do is we've got to take this into like more complex problem solving. This one isn't so bad, but the next one might get a little bit trickier. So example number 7 talks about a Russian nesting doll, or matryoshka, had its beginnings in 1890. The dolls are made so that the smallest doll fits inside a larger one, which fits inside a larger one, which fits inside a larger one, and so on. So you've got these dolls, and these guys open up, and this guy goes inside. And then this guy opens up, and then these two go inside. And that's basically a Russian nesting doll. In a set of 50 dolls, the tallest doll is 60 centimeters, and the smallest doll is 1 centimeter. And it says, if the decrease in doll size. So what that means is we're starting, our first term is going to be the 60 centimeter doll, and then we're getting smaller from there. Can you guys get your heads wrapped around that? Okay, when we look at this, there's 50 dolls. Guys, what would the 50 represent? Which variable would that be? Okay, so that would be your n. Like, you're just counting dolls. There's 50 of them, right? And it says the tallest doll is 60 centimeters. So basically, and we're decreasing in size. So we're starting at 60, and then dot, dot, dot. At the very end, my term 50 is going to be 1 centimeter. So how did I know that the 60 had to be my T1? Because it said it was decreasing in size. So we had to have our bigger size, and then we're going to end up with our smallest size. Okay? So it says if the decrease in doll size approximates a geometric sequence, determine the common ratio, express your answer to 3 decimal places. Okay, so if it's going to be a geometric sequence, and we've got this formula, Tn is equal to T1 times R to the n minus 1, can you guys algebraically determine the common ratio? Do you have enough information to find the common ratio? Then do it. Can you guys just check to see that you have this formula? Instead of writing 50 minus 1, I went straight to the 49. Are you guys okay with that? How would you algebraically determine your R? How am I going to solve for R right now? What would you do next? How am I going to solve for R? What's my next move? Perfect. Okay, so I'm going to divide by 60. I don't want to see this as a decimal. 1/60th is a beautiful number. So I'm going to use, how do I solve for R when the variable is the base? We're not creating same base right now because we know the exponent. How do I get the R all by itself? It's like a nasty 49th root of 1/60. Yeah? And so rounded to, how many decimal places? 3 decimal places. What did you guys get? Would I put plus minus on this? No, I'm not going to put plus minus on this because I didn't have an even exponent. And in context, could the size of the doll go from a positive number to a negative number to a, like, that wouldn't even make sense in the context, right? So guys, what did we get to 3 decimal places? What do we have here? R is equal to 0 decimal. What do you have? Do you guys know how to put the 49 through it? Okay, so I'm going to, like, 49, math, turn it into my x root. And then I have 1 divided by 60. Make sure that the whole 1/60th is in your calculator. Now, if you have an old calculator that doesn't superscript this, you might have to do this, 49 in brackets, and then math. Make sure you know how to handle your calculator. Are you guys okay with this? So rounded to 3 decimal places, what does this become? Okay, so if I want 3 decimal places, this 8 is going to bump the 9 up by 1, turning the 9 into a 10, turning this into a 2. You guys understand that this would get rounded to 0.920, and that's a rounded 0. Yes? Okay, so 0.920. Okay, so now, if we're going to connect this to a graph, remember that the general term, my T1 was 60, my common ratio is 0.920, so my general term is Tn is equal to 60 times 0.920 to the n minus 1. Now what we're going to do is we're actually going to type this into our calculator. Okay? If I wanted to fit this on the grid and I have n is equal to 50, I'm going to have to play with my grid, which means I'm going to have to play with my window. If we have 50 dolls and I want all 50 dolls to fit on the x-axis, okay, so this is my n, right? I'm not going to be 1, 2, 3, 4, 5, right? Like, we're not going to do that. If I need to get to 50, maybe it's going to be 10, 20, 30, 40, 50. So you want to adjust your scale according to the numbers that we've been given. My y-axis is my Tn. Now my Tn was actually the height of the dolls. Right? And we should actually connect that to the height of the dolls. What was the biggest height of the dolls? So maybe we're going to go 10, 20, 30, 40, 50, 60. And my T1 is going to be really close to that 60 because we, like, T1 would be right about here, right? Okay. I want everyone to take out their calculators right now. We need our calculator window to reflect what we have written down here. So this makes sense. I can fit my 50 dolls on the x-axis. I can get all the way up to 60 here. So first move you want to make, we're going to graph this. But the first move you want to make is you want to adjust your window. We have a negative 10 number of dolls. No, how many dolls do we have? We've got 50, so you got to make sure that your X maximum at least goes to 50. I'm going to go 60, just like because I want to see where the 50 is. And what did I count up by on my X-axis? My scale was actually 10. I counted by tens. Some people said 5 because it was every second line, so maybe you could, if you want to put 5, that's fine. Am I going to have a negative height for my doll? No, so 0. My maximum height is 60. I always like to show a little bit more than my max, and my scale is 10. So now this is how you're going to input your general term. So if this is your general term, the Tn is in the Y spot. And the N is in the X spot. So if you had an old calculator, you'd have to put brackets around this. If you've got a calculator that goes to superscript, so graphing calculator, push Y equals. So this is our window setting. We've got 0 to 60, 10, 0 to 70, 10. And then when you push Y equals, we're going to put that equation in. So 60 times, what was it? 0.92, that's 95. And then it's to the power of, if you didn't superscript, you need to put brackets, okay? And then it's going to be X minus 1. This is called an exponential decay graph, okay? The size of the dolls are going down, and it makes a curve. And you're going to see these so much next year in 30-1 or 30-2, okay? Now, if I want to plot this on paper, I'm going to push trace 10, and I'm going to plot that ordered pair. So if I trace 10, I've got the ordered pair 10 and then 28.3. So I'm going to, at 10, I'm going to be at like 28.3, so right about here. Can I get everyone just to show me that they have this? Push the graph, and I just want to see that you guys have it. Now, if you didn't change your window, you're going to have it all up in quadrant number 1, kind of. But make sure, I want to see that you guys did this. Everyone, put your calculators up. I need to see, if I say take out your calculator and do this, I need you to actually take out your calculator and do this, and not just watch me math. Okay, so guys, if you push trace 10, we get our 10. If you trace 20, we get our 20, so we get 12.3, right? So at 20, I should be at 12.3, which is approximately here. At 30, I'm at like 5.34. At 40, I'm at about 2.32. Guys, where was I supposed to be at for 50? I was supposed to be at 1. Because, so, when you guys were in grade 10, there was discrete and there was continuous data, right? Discrete was like, we want to see just dots. Continuous would be, we actually want to see the line. Because there's like 10 dashes in here, we're not going to get too caught up. I just want you guys to connect these so you can see the curve. And then I could kind of generalize. If I was at 15, doll 15, I'd be around like 20 centimeters, right? So we're just going to connect these. I started at the 1 and I stopped at the 50 because there's no more than 50 dolls. And your calculator doesn't recognize that. We started at 1, we finished at 50. Don't keep going forever because there's not an infinitely many number of dolls. Are we okay with this? So what the general term allows us to do is allows us to actually look at the graph. Only if the base is a positive number though. Okay, so now this is really important information that I need you guys to get your heads wrapped around today, because this is where it goes in Math 30-1. When you're thinking about something is growing by 5%, okay, so let's think about the population of Okotoks. Let's say the population of Okotoks is growing by 5%. to represent growth, okay, and actually here's the formula in 30-1. It's actually called the growth and decay formula, and so we're talking about growth right now. So this is where it's going to go in 30-1 and 30-2 next year. As if I say something is growing by 5%, 100% means it's staying the same. Like if I just say like, hey, nothing's happening, the population isn't changing, we would just multiply by 1 because 100% is the same as 1. Yes? Why is that a thing? That's not a thing in my class. Okay, so don't be putting your calculators away. We're still doing stuff. Okay, guys, 100% is 1, right? And then it's percentage of growth. So what you're going to do is you're always going to add your 100% to the amount that it's growing. So if I say growing by 5%, so notice that we're getting bigger than something. What are we getting bigger than? We're getting bigger than the 100% that we have. So if I say growing by 5%, your common ratio is going to be 100% plus the 5% growth, which is actually 105%. Guys, what's 105% of the decimal? That would be 1.05. If you take, when you see percent, you would divide by 100. So 105 divided by 100, we get the 1.05. If you see decay or decrease in value or depreciate, that means we're losing that amount. So if I say my population is decreasing by 5%, your common ratio is not 5%. Your common ratio is actually 0.95. And this is why. You're going to take your 100%, because that's what you had, that's what you started with. You're losing 5%, which means we're keeping 95%. When you're working with numbers, you don't work with the stuff that went away. You work with what you still have. So if I say it's decaying by 5%, you would take your 100% minus your 5%, and you actually work with 0.95 as your common ratio. So, and then we learned that if we have a percentage of, like straight out percentage of, like if I say 5% of, that wasn't going up by 5%, it wasn't going down by 5%, it's just 5% of. When the word of follows a percentage, this just means your common ratio would be this. I need you guys to notice the difference in the vocabulary here. If I say growth, it's 100% plus 5. If I say decreasing, it's 100% minus 5 to get your common ratio. If I say 5% of, when I say 5% of, then your common ratio is just the 5%. You don't have to do any work on it. Okay? So, and you're always going to convert your common ratios to decimals. Inflation, is that growth or decay? Is that going up or down? If something is, like if inflation is happening, are we going up or are we going down? We're going up. Okay, so when it says the word inflation is 3.5%, my common ratio will be 100% plus 3.5%, which is 103.5%. Now we need to write that as a decimal. What's 103.5% as a decimal? How do I get rid of the percentage? What does that become? This is my common ratio. Guys, if it's bigger than 1, it's growing. If it's between 0 and 1, it's going down. Okay? So this next example is saying that the number of fish are going down by 2% each year. So if my fish population is going down by 2% per year, decreasing, then my common ratio is going to be 100% minus the 2%, which means 98% remain. Guys, 2% of the fish are dead. They're gone. We're not going to work with like the fish that are dead. We're thinking about the fish that are still here. Does that make sense? Or the fish that have been fished out. So then your common ratio here, guys, what's 98% as a decimal? 0.98. So the tricky part moving forward with problem solving is going to be your growth or decay or of, okay? The number of rabbits in a population will be doubling each year. What would your common ratio be if we're doubling each year? Times 2. You're still packing up, the bell hasn't even rung. It's irritating me, actually. Time to take it out. Guys, if you pack up before my class is done, you make up that time after school. You're not in junior high. There's actually a break for a reason. Okay? Like, I don't get that. Like, we have a break. That's when you close your books. Okay? Guys, so it says the value of a computer decreases by 1/5 each year. Now you can have that.